Hey there, welcome to this second part of our .NET 6 series. So on the last part, Edwin showed us a couple of new C# 10 features. We also looked into ASP.NET minimal APIs, and we looked at some of the tooling around .NET. Now in this part, we are joined by Simon van der Meer. Hey Simon, how are you?
Hi, Sander. Hi, Edwin. I'm good,
Hey,
thank
Simon.
you.
Yeah, great for having you here. So this time we are going to look at the base class libraries, right?
Yeah, that's right. So we've already had Edwin talk about the stuff in the language and the tooling around the system, but we've also, of course, got the base class library where all the great stuff happens, the stuff that you actually use while coding. So yeah, I'm excited to tell you a little bit about that.
Yeah, and I guess we're only gonna see some of the features, right? Because the BCL is pretty big, and we try to keep these videos under half an hour. So
Yeah, and especially in .NET 6, there's a lot of new features that have been introduced. So yeah, it is indeed a subset of the features, but I've tried to choose the ones that that you will be most likely to use.
Okay, awesome. So let's dive in. Show us the money.
So let's get started with two new types that have been added to .NET, DateOnly and TimeOnly, which can be used to specifically work with either a date or a time only. We already had the datetime and the datetime offset properties in .NET to work with date times, but you always had and a date and a time. And with date only and time only, you can just use either a date or a time. A little overview of these two new types. One important thing to notice is that they will only be available from .NET 6 and forward, which means they're not available in .NET Standard. Unlike, for example, datetime. You will not only be seeing this with date only and time only, but with a lot of other new types that have been added and will be added to new versions of .NET. That they will only be available in that version and forward, and not in .NET Standard, because .NET Standard is slowly being phased out. One more important thing to notice is that system.text.json, the new JSON serializer in .NET, won't support serializing date only and time only in .NET 6. That support will be available from .NET 7 and forward. But in .NET 6, if you even try to serialize a date only or a time only, it will actually throw a not implemented exception. Just to let you know that you can't use it. It can, of course, be worked around with by creating a custom JSON converter, from which and there are a lot of examples already available online with which you can create one of those converters. New to soft JSON, the other big JSON serializer, will probably add support for date only and time only. It isn't there yet, but James Newton King, the author of New2Soft.json, has already said that they will probably be adding a target on .NET 6 from New2Soft.json and supports serializing those two new types. So how do you use these two new types? Well, for date only, there's three different type of constructors that you can initialize a date only with. The first one, the default initializer, will initialize the date only to the 1st of January in year 1. And then there's two constructors with which you can actually initialize it to a date and a date in a specific calendar. For time only, there's a default constructor which initializes the time only to 12 a.m., I think I should say. And there's a constructor from which you can initialize the time only with ticks. And then the ones you would expect to initialize it with a hour and minutes, and then two more overloads in which you can specify the seconds and the milliseconds. One more interesting thing is that time only doesn't support nanoseconds. Datetime also doesn't support nanoseconds. If you want to use nanoseconds, you would have to use a third-party library to be able to specify times until that level of accuracy. Then there's a few methods on these two new types which you can use. For time, there's a method from which you can create a time span from a time only, which simply is called toTimespan. And for date, to make a date time from a date only object, you can use the toDateTime method, in which you would have to add a time only as parameter, and then it will return the date time to you with that time that you specify. The default version of that method will create an unspecified date time for you, but there's an overload in which you can specify what kind of date time it should return for you. I already told you a little bit about the serialization of date only and time only, that it is not supported in .NET 6. But it's a little interesting to go a little deeper inside of why that is. Well, if you serialize a date only and time only right now with Newtonsoft.json, you would get about this result, in which it just enumerates the properties that are available for Newtonsoft.json to enumerate, and it will just drop those in a JSON object for you. And like I said earlier, for system text JSON, it will actually throw a not supported exception. And a little interesting thing to notice here is that it says it should be avoided since they can lead to security issues. So I looked a little bit into why it said it should be a security issue. And I dived into the .NET source code for that, which of course is publicly available on GitHub. And what they did, the change that they actually made, which is highlighted here, is that they just added the two new types, date only and time only, to an existing list of types that cannot be serialized. But if you look a little bit more up, there is this comment: there's no safe way to construct a type from untrusted user input, which talks specifically about the type class within .NET, which is apparently unsafe to serialize with system text JSON. And because date only and time only were just added to this list of unsafe types, it gives the same exception message for date only and time only as it would for a type class. We can serialize date only and time only, but like I said before, you can always just create a new custom JSON converter for date only or time only, and with that you can add the custom converter to your JSON serializer options and convert convert whatever entities that contain date onlys and time onlys to JSON using that custom converter. .NET has always had support for Windows time zones, and now with .NET 6 they have also added support for the IANA time zones, and they just extended the already existing methods which are in .NET to, for example, find a time zone by an ID. You could always enter a Windows time zone within that method, for example, the Western Europe Standard Time, and you would get a time zone info back which represented that time zone, that specific time zone. And now with the same method, you can also just enter a IANA time zone, for example, Europe/Amsterdam, and you would get back a time zone info which represents an IANA time zone. And then you can just use the already existing conversion methods, for example, timezoneinfo.convertTime from E to C, to use those IANA time zones to convert date times from one to another time zone. There's a few properties they've also added on the time zone info that you get back from find system time zone by ID. For example, the has IANA ID, which is false for time zone infos that have been retrieved with a Windows time zone, and true, of course, for time zone infos that have been constructed from a IANA time zone. And then there's also the try convert IANA ID to Windows ID and the try convert Windows ID to IANA ID methods to convert from a IANA ID to Windows ID, or vice versa, from a Windows ID to an IANA ID. And this is also where it gets a little bit interesting, because here you can see that there's not really a one-to-one conversion available all the time. For example, if I try to convert Europe/Amsterdam, the IANA time zone, to a Windows equivalent, you would get back Western Europe Standard Time. And if I then convert back Western Europe Standard Time to an IANA time zone ID, I would get Europe/Berlin back, which is not the Europe/Amsterdam from which the Western Europe Standard Time zone was created. So there's not a one-on-one conversion available, but you will always get a time zone back which has equivalent rules to the IANA or Windows time zone, which you insert into those conversion methods. There's a new method for retrieving some process information in .NET. Before .NET 6, if you wanted to retrieve the Windows ID or Linux ID, I guess, from a process or the process path, you would have to get the current process first and then check the properties on the process that you get back. From .NET 6, there's just two new static properties on the environment static class, which you can get the process ID in the process path from. For secure random number generation, there's also a new helper that's been added. One important thing to mention is that this new feature is really only about the secure random number generation and not about the pseudo random number generation, which is the less safe variant. Secure random number generation is the one that is used in for example, encryption libraries. Before .NET 6, if you wanted to get some random bytes, you would have to create a new RNG crypto service provider and use that object to get those random bytes. In .NET 6, they added the static method getBytes on random number generated class, with which you can just do that in one single line. There's also a couple of new Linq features in .NET 6, one of which is the batching and the chunking method, in which you can take a list of items and batch it down to several sub-lists with an amount of items that you specify. So, for example, I've got this list over here with 7 objects. And imagine if I want to split that up into equivalent size lists of, in this case, 4 items. I would use the chunk method on that list, the chunk link method on that list. And it would size down that list into 2 separate lists of one with 4 items, and in this case, one with 3 items, because there's no more items in the initial list. One more example of how you would use that in code. Imagine if I pull some messages and I want to those messages in separate chunks. I would use the chunk link method on those messages, and I would get an enumerable of messages back in those message chunks that are returned. And then I can process those messages with another method. Another great new feature in .NET 6 is the Parallel.ForEachAsync method to allow developers to asynchronously run tasks with a level of bounded parallelism. So before .NET 6, if you wanted to achieve that, you would have to use semaphores and keep count of the tasks that are still running, and use semaphore release in a try finally, try catch and then finally statement to make sure that your semaphores are released correctly and all that kind of hard stuff. But in .NET 6, there's a much easier way to do that. Like I said, the Parallel.ForEachAsync method, in which you can specify a parallel options object in which you can specify the maximum amount of parallelism that you would like to achieve. And Parallel.ForEachAsync will then always, in this case, maximally run 2 tasks in parallel, so you don't overload your service when considering bounded and unbounded parallelism. So, on to some more new Linq methods. In .NET 6, the MinBy and the MaxBy Linq methods have been added to allow developers to query a list of items based on the max or the min, based on a maximum value of a property or the minimum value of a property. So in .NET, you already had the min and the max method. Before .NET 6, you already had the min and the max methods, with which you would retrieve the highest or the lowest value of a property. But with the MinBy and the MaxBy, you actually get the object with that lowest or highest value property. And for the users that already use Linq, Linq has also has a MinBy and a MaxBy method, but it works a little differently from the .NET 6 implementation. And the difference can be seen here. These are the function signatures of the MinBy and the MaxBy in Linq and in Linq. And the differences between these two is that the Linq variant in .NET 6 always returns a single element, and the Linq variant always returns a I extrema enumerable, so a enumerable of items. And I'm a little bit surprised that the Linq variant of MinBy and MaxBy don't also return enumerables of items like the Linq variant does. Because take, for example, imagine I want to retrieve the last configuration of something. And I have 5 different configurations in my database, of which 2 have the same version. That would be exceptional behavior. That's something I would want to be able to detect in my code. And the Linq variants of MinBy and MaxBy allow you to handle that situations. In case of the Linq variant, if I run this piece of code, I would just get the version, probably the first version with the highest value would be returned. But if I use the Linq variant, I would always have to, because of the way the function works, I would get a list of items back, and I would have to use the single or default or some other Linq method to reduce that down to a single element. And because in this case I use the single method, the function would throw an invalid operation exception because there's 2 objects I would get from the MaxBy method. There's a couple of other Linq methods that have been added, and these are the distinct by, the accept by, the intersect by, and the union by methods, which all work similarly to the MinBy and the MaxBy methods. Then another small helper method that's been added, the ThrowIfNull method on argument null exception, which simply throws an argument null exception if the reference object that you pass to it is null. Then there's a couple of new power of 2 helpers in .NET 6, one of which is the bit operations round up to power of 2 method, which, as the name implies, rounds the value that you enter up to the first power of 2 value that it can find. In this case, I entered 27, and it will be rounded up to 32. If I subtract 1 from 32, I get 31, and that is a Mersenne prime. So I've also created this Boolean method, is Mersenne prime, to check if the value that you enter is a Mersenne prime, in which I use the other new power of 2 helper, which is bit operations is power of 2. And it will return true or false depending on if the value that you enter is a power of 2. Another new helper method that's been added to .NET 6 is the WaitAsync method on task. And WaitAsync will throw a timeout exception for you if the task runs longer than a specified amount of time which you specify in the WaitAsync method. In this case, I wait for 2 seconds until this task completes, and if it doesn't complete on time, it will throw a timeout exception, and in that case, I will write stop waiting to the console. and return a 408, meaning request timeout. So what's interesting about the WaitAsync method is that it doesn't stop the task from running. It will throw a timeout exception, but the task will still be running on the background threads, and it will also just run to completion, which you can see in this log that I've printed. At first, it will print the stopped waiting message when the timeout has passed. And then 3 seconds later, after the background task actually replies, it will still print the hello world message. And it wouldn't be a new .NET version if there wasn't a new timer in the BCL. So in .NET 6, they decided to add the periodic timer. And the periodic timer is a very simple to use timer, which you can use in asynchronous context. The constructor is very simple. There's only one overload, an overload in which you specify the interval of the timer. In this case, 1 second. With the wait for next tick async method, you can use a loop to iterate through the invocations of the timer. And the wait for next tick async accepts a cancellation token with which you can cancel the timer, or you can cancel the timer using the dispose method. One nice thing about this timer is that if your code within the invocation runs faster than the interval of the timer itself, it will make sure that the next invocation is actually on the next interval. So in this case, there's a little heavy operation which is called within the invocation. And within the heavy operation, it just waits half a second. But you can see in the logs that it will actually just run the print on each second, and not after each 1.5 seconds because of the heavy operation. So if you would compare this to the old way of doing a asynchronous timer, which I personally would implement using a while loop and a task delay, it is a lot harder to actually run the timer method on each interval, in this case on each second, because if I run this heavy operation of half a second in this example, you would see that it actually prints the message every 1.5 seconds instead of each second. The last new feature that I wanted to show you is the system.diagnostics.metrics module that they've added to .NET 6, which adds support for tracking and listening to and acting on measurements or metrics. And the way that .NET has implemented this is a bit interesting, because they have implemented the OpenTelemetry metrics API. OpenTelemetry itself is an observability framework for cloud-native software, meaning it is a new standard with which different technology stacks can communicate with each other using the same standards, the same frameworks, same tools, APIs, and all that great stuff. It is an interoperable framework for tracking metrics, but also logging and traces and all sorts of observability functionality. So the new system.diagnostics.metrics module in .NET implements the OpenTelemetry metrics API. There's a couple of new types that have been introduced. The first one of which is the meter provider. And one interesting note already is that this one doesn't live in the system.diagnostics.metrics namespace, but it lives in the OpenTelemetry.metrics NuGet package. But the next new type, the meter type, does live in system.diagnostics.metrics. A meter provider provides meters, is the way that OpenTelemetry works. And meters always have a name and an optional version. Meters can also be initialized individually without a meter provider. So you don't have to use OpenTelemetry.metrics to use meters. So meters can create instruments. And instruments are the types that actually measure stuff. An instrument has a name, a kind of instrument, and an optional unit and a description. So instruments report measurements, which are the metrics values that you measure. And measurements can then also still be listened to by meter listeners, which is the tracking and observing part of the new module that has been implemented. So I already mentioned that instruments have a kind, which means there's different types of instruments that are available. And as of right now, there's four different instruments supported in .NET 6. There are more instrument types in OpenTelemetry, but they've only implemented these four in .NET 6. And the first of which is the counter instrument, which is relatively simple. It's just a counter that only goes up. So imagine, for example, that you want to measure the amount of clicks that you do in a day. You would use a counter to measure that. The next type is the observable gauge, which is which tracks a series of readings. So, for example, if each 3 hours you go outside to check your thermometer, you could plot that data on a graph and have an interval of readings, just with that value applied to it. Next type is the histogram, which allows you to group values into ranges of values. And the last type is the observable counter, which is a lot like the counter and also a little bit like the observable gauge. But difference between an observable gauge and an observable counter is that the counter can only go up and the observable gauge can go up and down. So now for a little example of how you can use these new metrics APIs. We start off with creating a new meter, which you can give a name. And then we create an instrument from that meter, in this case a counter. And with this counter, I am counting the amount of readings that I am storing in our system. Another nice feature of the new metrics APIs is that you can add tags to measurements that you are making. Then for the listening part, there is a type called the meter listener, which you can initialize. And there's a couple of things you have to initialize before you can actually start listening to the measurements that you are making. The first thing you have to do is add a callback method on instrument published on the meter listener, in which you listen for instruments to be made. And when the instrument that you want to listen to has been constructed, you call the enable measurement events method on the meter listener, in which you add the instrument that you want to listen to the meter listener. The second thing you have to do is add a measurement event callback, which is called when a measurement is actually made. In this case, I add a callback, which is called when a measurement is made, and I retrieve the sender value from the tags that I add when making the measurement, and I record which sender is reading how many measurements. And I'm doing this because I want to be able to apply some throttling logic if a specific sender is ingressing or storing a lot of readings, and it is, for example, DOSing my system. The last thing you have to do before you can actually start listening to the measurements that you make is to start the meter listener. So the new metrics API allows you to measure specific processes that you are creating with .NET. But there's also a lot of libraries available which do a lot of instrumentation for you. For example, if you want to measure some more technical stuff, for example, the amount of requests that are recorded in ASP.NET Core, or maybe the amount of keys that you have available in your Redis instance, or maybe latency in your SQL queries. You can use instrumentation libraries for these 3 technology stacks, and they will do a lot of those measurements for you. The instrumentation libraries all have the same naming standards, which is OpenTelemetry.instrumentation. In this case, you've got ASP.NET Core and Stack Exchange, Redis, and SQL Client. And you can use those libraries to do a lot of the hard work for you. And there's also a lot of exporter libraries available for you to export the metrics that you've made to the dashboarding tool of your choice. So that was all that I wanted to show you. Once again, I've only shown a little subset of the new features that are available in .NET 6, but there is a lot more that's available. But for now, I'll give it back to you, Edwin or Sander.
Yeah, awesome. Thanks for showing us all these new features in the base class library. So, yeah, I was looking through the blog post that we got from the team with all the updates, because we had lots of updates and previews of .NET. And yeah, it's quite amazing how many stuff they were able to put into .NET 6. So it's definitely worth, reading up and make sure that you get to know all these new features, because they will definitely help you. So thanks for sharing that with us, Simon.
Yeah, no problem.
So yeah, everyone watching at home, I hope you learned a lot about .NET 6 and are as excited about it as we are. So thanks for watching. If you like dotnetFlix, please subscribe to our YouTube channel, and then we will see you at the next episode of dotnetFlix. Bye-bye.
Bye.
Bye.